Hi, future doctors. Welcome to the next class. In this class, we'll discuss about frictional force. So, when the frictional force is going to act, why it is coming, we are going to discuss. If you are taking an object on the rough surface, so rough surface means which is having frictional force, which can provide frictional force between object and surface. If you are taking an object of, let us assume, 5 kg or 10 kg. It is suspended by a string with the support of the pan, weight pan. Now, in this, if you are taking 1 kg stone, if you are taking 1 kg stone, now how much weight is acting downwards means 1 g, that is going to be 10 newtons. So now, will this object, 5 kg object will be moving or not means it is at rest position because it is 1 kg. Okay. So in this 10 newtons force is going to act. In this string also 10 newtons force is going to act, but it is not moving. It is not moving means what we said, it is at equilibrium position. The right side 10 newtons force is acting. It is not moving means left side also how much force is acting? 10 newtons force is acting. Then only it will not move. Therefore left side 10 newtons force is acting. Next up. I am taking here 2 kg stone. 1 kg, 1 kg. Then how much weight is going to act means 2g. That is going to be 2 into 10, 20 newtons. At the time, within this string also 20 newtons. Here also 20 newtons force. At the time, this one is going to move means for 2 kg, it will not move. Therefore, it is also increasing its opposing force. That is going to be 20 newtons. If you apply right side 20 newtons, left side also 20 newtons. Like this for 3 kg. For 3 kg, 30 newtons. 3 kg also it will not move. 4 kg also it will not move. If you are increasing right side force, left side force also is going to be increasing. So let us assume if we are taking 5 kg. At 5 kg, this object is ready to move. It will not move, but it will be in a position ready to move. So if you suppose here, if we hang 6 kg, then it will be moving. So till then, it is going to be at rest position. Why it is at rest position means its normal reaction, that is going to be equal to weighting, that is going to be 5g. So normal reaction is going to be mg, that is here 5g, 50 newtons. You increase it from 10, 20, 30, 40, 50. Till 50, it is not moving. If you are increasing upward force, it is increasing its self-adjusting force. Who is adjusting this force means object by itself, it is adjusting to not to move towards right. So this self-adjusting force, whenever object is at rest, we will be calling static frictional force. But this is having, for each object, it is having one maximum value. For 5 kg, we are saying normally, normal reaction equal to mg, 5g, 50 newtons. If you are taking 10 kg, for 10 kg object, if you apply 6 kg, it will not move because its normal reaction is going to be 10g, 100 newtons. So here, applied frictional force is always directly proportional to normal reaction, they will write. So this one only, if you remove one proportionality constant, we will write. If you remove proportional symbol, that is only mu n. What is this mu means? Coefficient of friction. So friction we will be having 3 cases. One is whenever object is at rest. Whenever object is at rest, that friction we will call static friction. Whenever object is moving or sliding, it is called kinetic friction. Whenever object is rolling, we will call rolling friction. So therefore, we will be having 3 types of coefficient of frictions: mu s, mu k, mu r. So which is highest means in this? always static frictional force is going to be highest. Therefore, mu s is greater than mu k is greater than mu r. So this is going to be coefficient of frictions relation also they are going to ask. Now, for one object, the frictional force is going to be maximum at one position, isn't it? What is that one position? I am going to explain for you. Let us assume for 5 kg, we said 50 newtons. That is going to be 5g, isn't it? For 20 kg, so it will be 20g. That is nothing but 200 newtons. So here, depending on the mass, it is going to be changing. For one object, it is going to be different. Which is different? Which is going to be applying maximum frictional force. That is only we will call Fs maximum. So this Fs maximum will be depending on up to what maximum value object will not move. That is going to be n. So Fs maximum is equal to mu s n. So for suppose, if you are taking an object of mass 5 kg, 5 kg, it is on the rough surface which is having coefficient of friction 0.5. Now right side. Now this 5 kg is applying how much maximum frictional force means? Fs maximum is equal to mu s n. What is mu s here means? 0.5. N is 5 into 10 because n is equal to mg. So 0.5 into 50. So this is going to be 25 newtons. Now this 5 kg object on this rough surface which is having coefficient of friction 0.5 is applying 25 newtons maximum static frictional force. Same 5 kg, let us assume it will be placed on 0.2 coefficient of friction. Then how much maximum frictional force it is going to place? Fs maximum is equal to same formula mu s mg 0.2 into 5 into 10, correct? So 0.5 into 10. So 2 into 5. It is applying 10 newtons. Now we will see. On this 5 kg which is having 0.5, I applied 5 newtons force. Then will this object move means? It will not move. Why? Because backwards it is going to apply maximum 25 newtons, but you applied 5 newtons. Therefore, it will also apply backward frictional force 5 newtons. Therefore, object will not move. Now, same 5 newtons I applied here on the second case. On the second case, I applied 5 newtons. Now, its maximum value is 10 newtons. So, it will not move. Therefore, here also it is applying backwards 5 newtons. Now on this object, first object, I apply 10 newtons. Now its maximum value 25. Therefore 10 is below 25. Therefore it will apply frictional force backwards also 10 newtons. Now on this I apply 10 newtons. Its maximum value also 10 newtons. You apply 10. At 10 it will be ready to move. Now see, very important you have to understand. On this I applied 15 newtons. So for this object, what is the maximum static frictional force? 25. We applied 15. Therefore, it will not move. Backwards, how much frictional force now? 15 newtons. Now, same 15 newtons if you applied here right side. Now, backwards it can apply only 10. But you applied 15 newtons. But maximum value is 10 newtons only. Therefore, it will move right side. So this object will not move for 15 newtons because its maximum value is 25 newtons. Now to move this object, minimum how much force you have to apply means 25, it is ready to move. So greater than 25 newtons if you apply, then this object will be moving. So till then, how much frictional force is acting? Same amount of frictional force is going to be acting backwards. This static frictional force will not make this object to move right side. So I hope you people understood what is frictional force, why it is going to act. Let us assume If it is moving right side, whenever we are applying F force, so coefficient of friction is mu. So this frictional force is going to be, still it is moving right side with acceleration here. Then what is net force means? F minus F. This is applied force. What is small f? Frictional force mu n. Resultant force MA. MA is equal to F minus mu mg because normal reaction is going to be equal to mg. Then acceleration is F by m minus mu g. Now, if this object is moving, whenever object is moving, if applied force is equal to frictional force, applied force is equal to frictional force, then Ma equal to mu mg. M will be cancelled. Then acceleration is going to be mu g. So on this equation, one of the year, they asked in final exam, 2024 maybe. So they gave coefficient of friction, what is the acceleration? If applied force is equal to frictional force. If applied force is greater than frictional force, then this is the formula for acceleration. Isn't it? Now, same question if they ask like this. So, M is the mass, right side you applied F force, not right side. It is making an angle, theta let us assume. Already right side we discussed. If it is making an angle theta, then this is going to be F cos theta. Of course, it is going to be normal reaction mg. If it is F cos theta, this is going to be F sin theta. Now, frictional force how much means? F is equal to mu n. From this diagram, what is normal reaction? So, always upward forces is equal to downward forces whenever object is not moving vertically. Therefore, mg is equal to n plus F sin theta. Now, n is equal to mg minus F sin theta. So many students will make mistake. This n value they will write unfortunately mg. But it is going to be whenever theta is angle is making, n is going to be mg minus F sin theta. Now what is the resultant force if it is moving right side with acceleration A means? Net force is equal to, what is applied force right side? F cos theta. F cos theta. Left side force? Small f. So F cos theta minus what is small f here? Mu mg minus F sin theta. This is going to be net force. Now what is the net acceleration means? We have to expand this. A is equal to F cos theta by m minus mu by m into mg minus F sin theta. Correct? So like this we can write. In this we have to remember mainly this formula and how to write frictional force if they applied force by making some angle theta. So this is the frictional force and acceleration formulas whenever they are going to ask the problems, and this is going to be logic how much force is going to be active. So simply they will ask an object is placed, some amount of force 2i cap plus 3j cap is acting on this. Then what is the frictional force if this object is not moving? They will ask. Right side 2i cap is acting. Of course 3j cap is acting. If it is not moving means how much frictional force is acting backwards? Frictional force is going to be minus 2i cap. Why? Because it is acting leftwards. Leftwards will be representing minus I cap. If it is at rest position, then only you have to take minus 2i cap. Isn't it? Like this also they are going to ask. So you can practice about this acceleration formula, how we are going to take whenever object is moving. So with applied force, in this case, how much is going to be taking place? Force value, acceleration value. Okay. So we will meet in next class. Thank you.